So let's take a look at Eugene's file. So we have kind of like some arcs that define maybe the handle part. We also have some profiles that define the front part. We have the blade. But there are some rotation problems. This one, for example, we can fix. Let's see. Oh, yep, there is the offender. So along that axis, the object was rotated. And we have to set the pivot point maybe correctly, because you can see pivot point is there. So we could shift control, middle mouse button, center pivot point, go. So you know that's there. Now there's an interesting behavior. If I type in 0, you would assume 0 means XYZ 0, so Y 0, but the object is not. So what I can do actually, I simply move it out, press then Alt, I press middle mouse button in this front view, and then I simply move it and snap to the grid. So this way, at least that blade is perfectly centered. Okay. Now let's take a look at those lines. I select them all and simply turn off the hull. Oh, there is a curve fragment there, delete. Okay. Good. Well, let's select all this stuff, put it onto this layer, and then set this one as reference. So if I actually would like to break this one down, I can actually build this one with two rings, one ring there, and one ring there. Okay, and then I need a profile there and there to describe this area, there and there to describe the lower part, and also here and there. Those profiles actually, oops, this one has to be aligned to that one, and this one has to be aligned to that one. And this open part later, we simply finish in Fusion. So this profile, at one point, I try to get really close, like there. And I try to draw actually those lines already, so they flow with each other. So I'm helping actually the Fusion cap command by building my surfaces accordingly. Okay, so then let's get started. I'm going to delete all these lines. Where are you? You should be in this layer. Assign. Okay, let's create a new layer. Good. So I go into the front view, double click, check off periodic, 2 segments. Okay, alt click. I have my end parts of my arcs left and right, so that's perfect. Click, scale, go to the side, and for example, maybe I'll go to here, rotate this a little bit, and I try to imagine maybe where those rings actually have to be. Scale this down more. See there, this has to be bigger. So maybe like this. Okay, good. Then copy and paste, and let's go to move. Move this one over. Information window, 0 rotation, move maybe to there. Scale it down. And actually, though, the CV and the hulls are really in my way, so I turn it off. Move this one down. Scale. Yeah. Okay. There. Okay. And actually here, copy and paste, move, zip, move it to here, rotate, and in left view, it's middle mouse button along the y-axis. Whoops. There. there, scale. Okay. So that's, for example, the way how it looks. Now I know actually that properly the front part should not be as wide. So I'm simply selecting those points, go into a side view, in my case front, orthographic, and then I press middle mouse button, and you see I can and then scale them along the y-axis. And maybe let's keep it. Can I snap? No, I can't snap. Okay. Let's keep it at this for the moment. Okay, good. Now comes the interesting part. I'm going to draw myself a line. Start from here to here. Another line down there. There, and then this actually I'm going to change into degree 3. No, I'm actually going into degree 4. So why 4? The midpoints of these lines I used basically to bend out as much as I need, and those endpoints I use to describe this curve, how it flows to this edge. Now this sounds actually really confusing, so let me make one 3 point and one 4 degree. Okay, good. Then I go into side view, this one, move down, move down, move down, there. Okay, and then here I can do it this way and this way. And you see actually how flat this one can get. Let's turn the visibility off here for a second. Let's select those two. And let's take a look. Really pay attention to how nicely this whole area curves progressively towards there, so I can lead this curve up. While here, this is a nice curve, but at the ends, it's actually rather flat. Here, it is more defined. So when, for example, now I'm going to create a blend curve between those 2 points. Let's take a look how the sketch looks. Okay, so this, for example, can tell me later how the part will pillow out actually in Fusion. So let's turn those points on. Let's go to here. Okay, so this curve actually now I make a degree 4, except, so maybe I'm trying to see how, for example, I can sculpt that a little bit more. Okay. Take a look here. Is there anything we can do here, for example, to push this one out a little bit more? So there you see, if I want the piece to push out more, I have to change the degree there. So this has to be a little bit flatter. If I want to go along the original shape, then unfortunately, probably the cap will be a little bit more flatter. That's just the way how mathematically the surface will flow. Okay, good. Let's keep that for the moment. And now we're going to pay attention to this part. And here I'm going to use a degree 4. Okay. And another curve here and zip. No. There. Degree 4 the same, except now I go to align and say G2, this edge to this edge, this edge to this edge. Okay. Then I can select this CV and, for example, push it to there. Now the question is if maybe, I would say I do the same a little bit. Woo, there and there, maybe. So you see, I'm partially building already how this could end later. So I don't want that actually to be, see right now this is G1 tangent. So if we would cap this one with the patch tool and turn on tangent, it would be flat. So I need this to pillow out a little bit. And again, if I now plug myself in a blend curve, okay, that's one of these cases where maybe the blend curve is not the greatest tool. Let's see. That's okay. That's the part I wanted to have. Okay. Change the direction, please. Yeah, okay. Well, I can simply create the same this way. Degree 5. Spacebar, okay. And then in this one actually I line this one to here. No, what's happening there? This one to there. I must have used actually the wrong direction. Cling. So, oh shoot, I deleted my line. Okay, let's create it again. Not a big deal. Align you to this one and you to this one. What the heck? This doesn't make sense. Oh, okay. Let's see. Oh, okay. Well, there. Interesting. Okay. Let's see what happens when we move these points there. So that was it. I was actually leading that curve already way too much in. And maybe the same there. Okay, so that, for example, doesn't look too bad, but now we see this whole thing is terrible. This curve cuts under, well, and that's because this curve here, we have to adjust a little bit. You can see by pushing it down, because this curve aligns to it, and pushing that other curve out. So if we want to have a mathematically sound and smooth transition, this sketch line we have in the background, we simply have to let go. So, and I think I would say there's now our design, and this looks actually pretty nice. Okay, so this was actually pretty much part 1, how to create all the profiles. Now we can actually create a layer and then actually start the skinning. So let's take a look. 2, okay, so do we use this cross section and this cross section along this rail and this rail? Then this cross section and this cross section along, okay, again along this rail, and then here I want to use not the curve but the rail surface. And then also rail 2 should be curvature and not position, because I want that surface, of course, to flow into it. So here rail 2, zip, nothing. Let's take a look, turn on the zebra and take a look at that. Looks pretty good. Okay, let's turn on the symmetry to see if how stuff looks along the symmetry. Let's rotate our view. And garbage. Probably that's. Oh yeah. Wah, wah. Rails. I messed up the lines. So undo. That's my, yeah. Those arcs are actually our profiles, and the rails are the curves we created. So nope, not this one. Rail, U, and U. Rail 1, rail 2. That's how it should be. So let's take a look there. You see, maybe to reinforce the difference here. So you see the zebra line is actually pretty good. So if I go back and, for example, say generation curve, rail, rail, you see it breaks. Now the main reason is simply, how could I say that? I would assume, well, you would assume this is all a perfect circle, half, and here's the other half. So if we push this generation curve along this path, it all should work well, but it doesn't. Now let's see if we turn on implied tangency. It works, but then we get this crap. So that's not really usable. No, I built actually everything with those rings. That's the reason why 2 segments. So I get 2 circles or 2 arcs that are perfectly to each other. So actually I could use this one and this one, my perfect circles. So if I create now a surface from them along their edge, they will flow perfectly along each other. And then those are my rails. And there it is. So here again, circle and rail surface. And then that's the first rail and the second rail. Let's take a look. Okay, on top is good. Here it's terrible because now Gen 2 has to be curvature and flip. And there it is. Now we see how it works. Okay. And that's basically now how we can quickly create the shape. And you see the transitions are actually really nice and smooth. So again, breaking stuff down into smaller elements. And then sometimes the order is really, of course, important as well, obviously. So now maybe we can take a look at, do we really need this piece to be so wide? See, our blade is pretty pretty narrow. So if this is 1 millimeter, let's maybe see what's the thickness. We could go to measure the distance. So from here to there, stop. So 8 millimeters plus 8. So that actually, that's a lot. So maybe we don't want that. So let's maybe, what are we going to do? Yeah, we're just simply trying this, changing this curve. So show me the hole. And whoops, same for that one. Okay, then select CVs. I select all those CVs. And again, this is really crucial. Currently, those are really perfect arcs. So if I go to scale, just down press scale, I'm breaking the perfect tangency I crafted. So you see now here the tangency fails, which actually, if you want to have something like this, that's the way how to do it. So round, perfect, and then to the end, it starts getting this transition. Think about like some cars also where you have creases. basically you have a surface, you have two surfaces that are aligned to the other two surfaces smoothly, and then later it starts to break. But again, in this case, we do not want that. So I'm selecting all those points, going to front view, go to scale, and then because I'm orthographic, again, middle mouse button, and I just scale it along the y-axis. Till maybe it starts looking kind of like something I'm intending. So 1 millimeter, that's probably 2 millimeters. If we want to have a 2 millimeter thickness, yeah. Now, to be really precise, I'm going to put down a dimensional note. So there and there, 1. So here's 2 millimeters. Okay, now I can see actually how far I can move it. So up in the top, probably, let's take a look there, how much space I have. So here's one point, here's the other point. Let's take a look, 1.5 millimeter. And let's measure another distance down here to there. Whoops, wrong one. There, 2 millimeters. So actually, I can maybe bring this blade down just a notch. There. So, whoops. Let's go to there. Okay. Select that one there. And then let's see, where are 2 millimeters there? Yeah. Okay. I would say that looks decent now. Now I can keep those dimensions or simply remove them. Okay. Let's check maybe one more time how everything looks. See, that seems to be nice and smooth. Okay. Yeah. Cool. Let's keep it that way. So I think at this point I would say everything in Fusion more or less is done. Just to summarize, I hope you saw that I kind of like tried to block out where can I put down construction rings, and then how I put down also the first set of rail profiles, then the next sets of rail profiles were aligned to it, and then also, for example, here at the end, let me select that curve there. With specifically this last CV here, I started building actually already the transitions so that when we create the cap, I know how the cap probably will look like. And then also to get actually kind of like this shape of my sketch, realized I just needed to adjust all the CVs of this curve, which forced me to sacrifice a little bit of the initial design intent. For example, Eurgene has inside his sketch, but properly the sketch was simply eyeballed. So like you make a study in terms of how maybe you would like something to look. And then you have to start building a mathematically sound model where the transitions are good. So you really have a high quality sculpted presentation of it. So there's always a certain level of change in the design. And that's, for example, why I also say sketches are great. Don't fall in love with them. At least don't expect to be able to turn a sketch into a perfectly matching computer model. It ain't working. Okay, so I stop here and then I will go into Fusion. So here we're in Fusion. Let's open the file. And well, most of the stuff transferred over pretty well. In this case here, for example, I can see some of the shells are not stitched correctly and they're kind of flipped. So let me take a look at what I have here. So here's my body. That's actually my blade. So this one, for example, I call blade. And all those four, I could flip the sides if I want to, but if I stitch, it does it for me. There. Okay. I still have to flip it. Okay, reverse normal. There. Okay. You also see I'm currently not inside the design timeline. So because I just want to finish that design in the direct modeling first, and then I put those objects into the design timeline. So let's see with the patch what happens when we cap this one. Let's say tangent or curvature. See, curvature doesn't really do a lot because I built already those surfaces so that actually that surface fusion is going to build for me will nearly be pretty much perfect. And let's go to patch one more time here and there, tangent. Let's take a look. Yeah, okay. See, also here, because I guided those lines a little bit, it helps tremendously. Okay, so and let's stitch all that stuff together. Perfect. So take a look at that. Nice and organic shape, and the rounds are pretty, the ends are pretty good. Now let's make actually one comparison. I'm curious now because currently the limitation of the fusion patch is I can select tangent and curvature. However, I do not have any further control over kind of like the scale of the tangency. So here, maybe on a new layer there, file, import file. There's the step file. Let's bring it back in and overlay it because I'm curious how far Fusion got close to that line. So there you can see, for example, it follows it and then it stops it. And that's actually the blend curve. So you see actually that the fusion surface is really not that far off. It's pretty close. What about here? Obviously, that one is somewhat different. This one also can't really work because I'm blending between this line and this line. And the surface has to also be blended along those sides, which is why it's being pushed in. So that's obviously okay. However, just as for the sake of a comparison, you see this is actually a pretty good match. You also actually, if I bring this one back and let's turn on the CVs. No, I cannot. There. This is stitched, so unstitch this one. You see actually that this is a rectangular surface which is trimmed, and you also see how dense actually the control points are. So if I now would need to adjust and alias this model, I would refuse doing that. You see that the rest of the design is very simple. Now this is a good comparison between what you can sculpt in alias with the tools. That's the reason why it's a little bit harder, but the output is cleaner. And you see that the surface from Fusion, inside Fusion looks good, but it is a really dense surface. But you know, for this cap, that thing we only do in Fusion anyway, so it should remain in here, so we're actually good. Okay, so his next steps then would be we want to cap this part. So let's go maybe split this body along this plane. Is the plane centered? So my object is centered to the world. So I can actually simply select this plane. But hold on, before I do this, I'm actually turning on the capture design history because I really do not want to destroy, for example, my model, or really actually trim it. This is now an interactive split. So I can always go back to my base feature and the stuff is still there. Okay, so there's that. Let's see, for example, how the shelling will perform. This is a pretty simple form, so the shelling should actually work pretty reliably. And Houston, do we have a problem? Nope. Okay, it took a little bit longer. And this corner here where my spinning ball is pretty tight. So the outside surface. All this area here is easy, but those are rounded, tight rounded corners. So offsetting them created a lot of problems, as you can see. So what might be an alternative approach to that? If I'm okay with this, it's also the inside. Okay, let's say Fusion would have bugged out, and then actually maybe we could have done that. Go to edit. Now this blade height, this face actually I delete. What? Okay. It exploded. Okay. This face delete. There. Patch. Nope. Okay. Stitch. So it's all stitched together. Patch. This one. Okay. Select everything. Stitch. Okay. Finish base feature. So you see, actually, this was a nice demonstration for when to use the base feature and when to use the solid modeling. So let's go to here and let's go back to there. Delete this one because this was really blazing fast how it calculated it. Zip. Yeah, so you see actually that how fast now that surface is generated. So in case I'm happy with this, then maybe I could go ahead and say, I still would like this one to be rounded. Yeah, so 1 millimeter. I can't make it 2 millimeter because then it interferes. So maybe I push this one to there. And let's see what we can do. Nope. Fillet this one 2. 1. Oh wait, actually, hold on. I do this here at this stage. So near tangent sheet ends. Yeah, okay. Maybe let's keep it that way. Okay, good. Then we can split it, zip, and then we can shell it, zip. Okay. And then let's put the blade back in. Okay. So at this point, now we can actually think about how we can create the web and then the locking system and then later the key. I will since I have the web and the keys in other videos, I'm not going to redo it here, but I'm going to use an alternative approach actually for the keys, the web system here, to create those helpers. So keep in mind this should be injection molded. So the shell has to be able to be pulled out. So I'm going to create myself a sketch. I'm offsetting the plane first, and I'm doing this minus 0.1 down. So not really a lot. So I still have 8mm of material because my blade is 1mm wide. So then onto that thing, I'm going to create a sketch. And I'm placing this line just right here, there, and stop sketch. And before I continue, just want to see if this trick actually works out. Oops, wrong number. There, perfect. So you see, actually, I can use this tool to create first a web and in addition create a bigger web, which then maybe we can use for building the locking mechanism for the blade. So 6mm, perfect. Let's go back, edit there, put this line down there. Okay, I don't know if this one is really centered, so try it out this way and maybe put one line down here. Hey, what happened there? No. Zip. Yeah, maybe like this. Okay, don't need any more lines. The blade pretty much has good support. And then edit and Mac Ample PC control, click those what cannot intersect profile. Oh, that's rubbish. Hold on. Why does this not work? That shouldn't really be a problem. So press cancel, delete, and let's see what the problem is. Okay, web U 2mm. And your profile curves can intersect body or flip direction. We did. Okay, well that is kind of annoying. So let's check if maybe by accident I did anything different. Are these lines all on the same plane? They are, so maybe let's offset this one. Oh, stop sketch. Edit this one. And maybe make 0.3mm. Not really perfect, don't want that, but let's see actually if this works. Okay, so go to the web function there. 1, 2, 3, 6mm. Now it doesn't work. Okay. What about this one? Oh, okay, that front one actually has problems, probably because of the curvature. There's too much going on. Maybe let's see if actually we can trick it by doing something like this. What happens if I push this one in here? Oh, great. Zip. Zip, because those cavities I don't really want. Okay, this is kind of terrible, so trying to maybe do it this way. Ah, sweet, actually I can push it over. Okay, so that troubleshooting worked out, so we can clearly see those actually work at the moment. Now let's take a look at the this one because it's so cranky. And I'm curious. Yeah, close, cancel. If maybe we move this one first to here, if that's going to work, and then I step by step going to bring this line over. Still doesn't do it. Okay, let's see. Edit. There. Now that I call rubbish. Okay, edit the sketch. You delete. That's kind of stupid. And you copy and paste. Move this one to there. Stop. Edit. Okay, so main reason why I did this was simply now maybe I'm simply, as you see, I'm going to move the stuff in there. Nobody tells me it doesn't work. I will make it work there. I'm not sure what was wrong with that line, but simply fixing it this way helped. So, okay, maybe at this point, let's try this one out again. Let's bring back our offset distance. Does it all work? It actually does. So that is really nice. Okay, and then at this point, let's go combine this part, minus, and keep the tool, cut, hide the blade. Let's hide all our sketches, all that stuff. Let's go to material appearance, maybe give it something we can see. Let's rotate and look what we have there. See? The perfect geometry for if we would open this one, the shell actually, the blade to snap into, to be supported, and it's not going to slide. Now, as I mentioned before, the rest here is left to be done with the webbing. Maybe those were pretty thick webs, but there we don't need it. And then actually the keys, and then we can duplicate those parts and then have another cylinder inside the keys. That one is the female to cut out and the male to join, and then we're done. Just to check this one, maybe I make those actually 7mm, and the main reason is okay to see if maybe I do not want this one a little bit lower. So this is actually a solid block. This one I move a little bit away. There and there. Now keep in mind that's a small part. Currently those sides do not have any draft, so getting this out of a mold might be tricky, which is why I opened more spaces, and later there has to be a small oh look, it has to be longer there, a small draft added to these sides, so when you pull it over a mold it will be better. But for example, for prototyping purpose, this is totally sufficient. Okay, so that was then the second part, how we can finish this thing in Fusion. Make sure the the blade is secure. And yeah, that's everything.